All right. So, like I said, I'm going to do the next part of this. This has to do with cofunctions. Again, like I said, the idea of cofunctions is if we're always talking about a right angle, then what would be, let's call this, well, let's call it theta. What would be the sign would be opposite over hypotenuse. But if we think about it, let's say we have this, I guess I should have called that uh, alpha. Let's say we have this beta. The idea here is the sine, the opposite over hypotenuse, would be the cosine. So, in other words, the sine of theta is going to be equal to the cosine of beta. So that's the main idea here is because of the fact that a triangle has 180 degrees, if we're dealing with a right angle, this other angle would be the same thing. So that's this idea that sine of theta, or another way of saying this, instead of saying, imagining it as a triangle like this, we could say that the sine of theta is equal to the cosine of 90 minus theta. And the reason why this works is if we think that a triangle has 180 degrees, but we always have to use 90-degree angles when we're talking about trig, then we're talking about this other angle over here. So automatically we have to think 180 equals 90 plus theta plus our beta here. So that's one of the reasons why we can just say that 90 equals theta plus beta for lack of better angles on my part. I should have said alpha and beta. So let's get into this. So if I say sine of theta at 0 degrees, so in other words, my angle is 0 degrees. So on a unit circle, I would not have a sine. There's no y value. So I would say that this would be 0. Now, what's 90 minus our theta? In other words, 90 minus 0. So that's 90. So what is the cosine at 90? Well, at 90 degrees, cosine would also be 0. We're at 90 degrees. There is no run. There's no x value. So that's how come it's going to be 0 as well. So let's take a look over here. So now we're going to say sine at 30. So at 30 degrees, I really should pull out the unit circle, but we're just going to say 30 degrees is the short side, which is 1/2, right? So if we're saying 1/2, then our sine is 1/2. And then we're going to do 90 minus theta, so that's 60. Now we're going to look at the cosine at 60 degrees. So we go a little higher. So this is a very tall angle, but it's a short angle, at least compared to the 45-degree angle and so on and so forth. So if I'm doing this, I'm going to say that this is also going to be, since it's short, it's also going to be 1/2. And you guys can kind of start seeing the pattern that's going on here. So if I say sine at 60 degrees, well, that one's a very long angle. So that's going to be our, let me insert my formula here. I'm going to say the square root, oh, first let me make it a fraction, and say the square root of 3 over 2. All right, and then that's going to be 30, because 60, 30, 90 minus 60 is 30. And this is also going to be the same thing here. So I'm just going to copy this and just paste it here. And you can, like I said, start seeing the pattern. Well, this is going to be 1 at sine, because sine is straight up and down. That's going to be 1. We already know this is going to be 1. And why is that? Because cosine at 0 is 1. It's all flat. All right, so let's take a look at 120. Well, 120 is essentially 60 degrees just on quadrant 2. So if we do quadrant 2, well, sine at 60, sine at 60 degrees is square root of 3 over 2. And we know it's positive because it's still in quadrant 2, so it's fine. We don't have a negative y there. And then 120 minus that, that's going to be negative 30. And negative 30 is going to be basically the um, same cosine as positive 30. Again, remember cosine is our x value, so whether it's positive or negative on here, it's going to end up being the same. So it's okay to just say that it's also that because it's short angle and it's positive. So if we do this one, well, this is essentially the same thing as 30 degrees. We're going a little bit further now, and we're going to say 30 degrees. Let me do it in black, which again, we said this was a very short angle. It's long as far as how wide it is, but it's still short. So that's going to be our 1/2. So I'm just going to put in 1/2. We subtract it, we get negative 60. And negative 60, again, it's going to be the same thing as positive 60 for cosine. So this is still also 1/2. All right, and let's do this. So this is 180. That's going to be 0 for our cosine. And that's going to be 90. So that's also going to be 0 for cosine of 90, or I should say negative 90, is also going to be 0. So we see that this pattern keeps going on. Now, what can we say here? Fill in the following. Okay, so we're going to do the exact same thing, except it's going to be a little backwards. Cosine at 0 degrees is 1. Cosine at 30 degrees, again, this is longer than it is tall. So that's going to be our square root of 3 over 2. So I'm just going to copy the square root of 3 over 2 from here. And then here I'm going to get that 1/2 because at 60 degrees it's short, but it's very tall. At 90 degrees, we don't have any more. It keeps descending. Remember how I said this? We're not doing the 45-degree one. They didn't want us doing the 45-degree one, I think, because of the fact that 45 degrees is the same for cosine and sine. So that's why we don't have anything. And then this, like I said before, 60 degrees, but on the upside. Now, here's the interesting part. This is going to be negative for this. It's actually a negative 1/2. Huh. This might come in. This is interesting because before we didn't really have to deal with these negatives. They were all quadrant 2. We were dealing with 1. So let's see how it affects this. Well, this is negative 30 degrees, right? Well, negative 30 degrees actually does make our sign go negative. Our y value is negative. So luckily enough, this is still negative 1/2. It still works out fine. Now let's do this next one. Well, this is 30 degrees. Oops. And did I do this right? So, oh, I'm doing cosine. That's right. Cosine. So this is going to end up being negative square root of 3 over 3. And like I said before, um, this, if we look at it, is going to end up being negative like over here. So it still works, interestingly enough. So this would be our negative 60. So this thing still works even though we're dealing with like negative angles, just because of how far it is. So subtracting that 90 degrees, even though we're like over here, it's still going to affect it over there. All right, so now we get this 180. So if we're going to do 180, 180, our cosine is 1 again. And this would end up making it negative 90. And like we've been saying here, negative 90 is down here, negative 90 degrees, which would make our y value negative 1. Sorry, guys. So everything holds up. We still have everything exactly the same. it just works out perfectly for us. Um, so this is the interesting thing about cofunctions. So cosine and sine are cofunctions, meaning that they're kind of complementary. 30, and this will be 0, and then after that we go negative. All right, cool. So self-evaluation, this is mainly just the interesting part on, I would say, like, the interesting part of this, every time I do cofunctions, I'm like, why does this work again? And it just kind of does. The best way to picture it is that triangle. If this is 30 degrees, this is 60 degrees, and the opposite of one angle is the adjacent of the other. So this angle is the opposite, but for this angle right here, it's the adjacent. So that's how come these end up being co-functions of each other. So it's weird. I always have to picture a triangle when I'm doing these. So let's take a look at this. So they're kind of saying like, hey, this works because of that triangle thing. This is 90. I just like picturing it as, instead of doing that, just imagine that there's another angle right over here. They're doing it as these angles are congruent. I just like picturing it as the other angle. It doesn't make sense looking at the unit circle that way, but it just makes sense overall. All right, let's keep going. All right, so the identity for cosine and tangent. So use cofunctions on identities. So this works for other angles. So if we're saying cotangent would end up being this. So how can I describe this? So cotangent is 1 over, so cotangent is equal to 1 over tangent, basically. So that's where they get this from. And I'm not sure what is going on here. Cotangent's equal to that, and that 90. Best thing I can do to kind of describe this is, if we're looking at cotangent, we have this angle here, and we're going to do the angle beta. And again, the opposite and adjacent switch over. So basically, what this is saying is cotangent of beta is equal to tangent of theta. Or you can just see it as this and that are equal to each other. These are equal. So inverse functions are the same thing. And this kind of makes sense here, the cosecant and secant. Well, guess what? You can see the proof here. We already know that cosine and sine are cofunctions, so it would only make sense that they're reciprocals. So their reciprocal functions would also be cofunctions of each other. The interesting part that they bring up here is that the um, the cofunction of tangent, or the reciprocal of tangent, it's also its cofunction. And that's just because we have to remember that tangent is opposite over adjacent. So by saying that we would say that cotangent of beta would still be the exact same angles or same sides that they're talking about here. So if we have a triangle and we say this is A and this is B, then if we're for theta, then we would say the beta would be here. So if we're doing beta, it would still be A over B, because now we're talking about the other options. So to me, the cosecant and the secant, they just make sense to me. I don't know how else I can describe this. They just kind of fit. The reciprocal functions aren't that bad. The only thing that you should find interesting is the reciprocal of tangent is also the cofunction. So applying this in a triangle. So applying this will help us figure out a little bit more of this, is what it's saying. So recall that these, substitute that in. Recalling their 90 functions. So basically, this is just like an easier way of figuring out an angle. So let's kind of take a look at this. So what is the value of this? So this would tell me that, let's see here, what sine of x. So this tells me that I have to figure out tangent. Where does tangent theta equals square root of 3? Well, let's think about this. So this has to be, since tangent is the same thing as y over x, I have to think of somewhere where the y is square root of 3 over 2 and the x is 1/2. And the reason for this is square root of 3 over 2 over 1/2. We would end up flipping this and multiplying it. And the only spot I know where that happens is we're going to have a very tall angle because the y is a lot, and it's going to not be that far away. So what'll happen here is I look at this, I'm like, oh, 60 degrees. So theta has to be 60. Well, if theta is 60 and 90 minus x equals 60, then my x has to be 30. So this allows me to, instead of going x over y with the tangent and then figuring all this out, I'm just like, okay, well, I know 90 minus x, this is going to be 60, so I can just move it over from there. All right, so I'm going to say that my answer is 30. Let's see what? No way. Tangent theta, think whose angle is that? Yeah, where my tangent is 60 degrees. I'm going to have a very tall one and a short. I don't see how this could be anything else. But cosine is if this is 60. Yeah, it has to be 60. I'm just going to verify using Desmos, the scientific calculator. Function tangent of 60 degrees. Oh, shoot. Inverse. What is going on here? Oh, shoot. Inverse tangent of square root of 6. Okay. Hold on. Sorry, guys. Where's the square root? Oh, there it is. Square root of 3. This will give me my angle because I'm plugging in the side. I don't want radians. I want degrees. 60. Yeah, that's 60. What are you doing? I meant that this is a multiple choice question. You can't be wrong on this. The only thing I can think of is, oh shoot, it's going to be negative something, isn't it? 90 minus x equals 60. So I get negative x equals negative 30. Whoa, my math was super off on that, guys. Wait, no, yeah, that's 30. What is wrong with you? 60. Oh, because it's a cofunction. Yes, it's tangent 30, but I want this to be 30. So that was smart on their part. Um, because I have to subtract the 60. This is a theta. If I said tangent of theta works out this way, then this still has to be the theta. So they tricked me. I was like already trying to metagame it, and that did not work for me. All right, so now I'm gonna have to figure this part out. So use the cofunction identity do this. Well, this tells me that this would be the same thing as 90 minus what angle? So sine is equal to 90 minus one angle. So I would just say cosine of x. Or they're cofunctions. So I could just say cosine of x, and this should be my answer. So yeah, because they're functions, what's happening here is I already know that pi over 2 is 90 degrees. So this is already saying sine of 90 degrees minus x. And from what I learned in that last one, I've learned that I'm not going to get tricked again. And I'm saying this is my theta. So instead of saying 90 minus theta, I'm just going to switch this to cosine. All right, so let's do this cofunction one. Okay, so remember that one that I said that the reciprocals are also cofunctions of each other? So the cofunction of secant, or cosecant, is secant. So I'm just going to say secant, and I'm going to make sure to remember to use this function. I can't say x because it's specifically saying theta. All right, now it's just pulling my leg at this point. What is going on here? That has to be it. Secant. Oh, I think they want me to actually use this. If that's it, then Admentum, you're just being picky. Admentum, you're just being picky. Can't type in my answer. I have to use their special function. All right. So if I look at this, they're trying to trick you. It's just a very fancy way of saying if you distribute this as 120 minus 30 minus a. So this is a fancy way of saying 90 minus a. It's kind of tricky. So then let's look at the cofunction. So the cofunction of cosine is sine. And for some reason, I was able to type in sine last time, but it was picky with secant. So I'm just going to keep this going. And I'm just going to type in A because I don't see any A to type in there. So, like I said, it was just a trick question. It's like, oh, look how weird this is. Not really. It's 90 minus A. All right, and our summary. So this is just our addition formulas for some and different formulas. Again, use that sheet I gave you guys in your pre-calculus thing. You can go to classwork, go to trig slash unit circle notes. This is a good cheat sheet for you guys. All right, so moving on. So that's basically it. And then if we move on from there, we learn about how we can use this to solve it if we're adding two angles together. Or here's all I recommend actually copying this down. If you guys don't want to print out the sheet, you guys can actually copy down slide 34. It's pretty useful. And as always, watch the video before you do your mastery test just to help you out. You know, you never know. Give me a second here. Yeah, I forgot you guys don't have a practice. But yep, definitely check out that mastery before you try it out. All right, guys. Talk to you later. Or see you tomorrow. Bye.